Are we ready for more? I have a little bit more to share on nonlinear models. Nonlinear models essentially just means that your dependent variable is not continuous, but for example, binary. And that will then help me understand a few things, or maybe I should start this way. The difference between a linear and a nonlinear model is that the coefficients are not so easy to interpret. In a linear regression model, a 1 unit increase in my independent variable, for example, a 1 unit increase in the hours worked per week, leads to a coefficient size increase or change in my dependent variable. If I look at my regressions earlier on, let me just jump back to this earlier regression. If I look at this result, then 1 hour more in work results on average in a roughly 7% increase in my wage. That is now the rough interpretation. And in this case, I say the percentage because my dependent variable is log transformed. Otherwise, it would be a unit increase. If it were not transformed into a log transformation, it would be just the number of dollars I would get more for each hour worked. So for example, if I just add wage, then 1 hour more in work results in the coefficient size increase in my wage. So this would be probably what, 5 to 6 cents, I guess, if that's the unit. That will be the typical interpretation. If I go to a logit regression down here, then the relationship between the dependent and independent variable is less straightforward because we don't have a linear prediction model, but we have essentially an S-curve in a logit model. And the slope of this S-curve is, of course, different at every point estimate. I also have a YouTube video on this. If you want to learn more about this, check out my website. You'll find all the videos there and can look at logit regressions in more detail. Now, I'm going to run this logit regression, and again, it includes an interaction term. We already know that the two hashtags here indicate that I want to interact, that is multiply two variables. In this case, grade is the number of school years, and then race is the categorical variable that we had earlier. It had white, black, and other. And the C dot means that we have for grade a continuous variable, and for race we have a categorical variable. It is not continuous, and that's here particularly important, so that Stata does not treat race as a continuous variable. It has 1, 2, 3, but this is not a continuous variable. It doesn't mean 1 is higher, lower than 2, or 2 is or 3 is higher than 2. It is distinct categories, and that's what I need to indicate here. So very important to not forget the I dot. The rest is very similar to what we had before. First of all, I store the cutoff points for my moderator in my local, so my memory, or my independent variable as well. This case for grade, it's a continuous variable where I store the maximum and the minimum grade in my local, and then I can compute the margins for the minimum to the maximum grade with intervals of 1. And I also want to look at whether those margins, whether the relationship between my schooling and the wages, whether and the type of job that I'm earning, whether I'm the type of job that I'm taking, whether it's a blue or white collar job, changes as a function of race. Let's take a look at the results. Then these things become a little clearer. I now computed my margins again. And as before, I have my margins plot with a few options, labels, titles, beautification. Oh, sorry, I need to run the whole thing. Otherwise, part of what is stored is not in the memory. And here I now have my output for a non-linear regression results. As you see, now this is not a linear prediction anymore, but we have a kind of a curve. And that is what you would typically see if you have a nonlinear results or nonlinear regression model, that the results and the visualization is also kind of a different type of shape because the margins are different at every slope point. What I see in terms of interpretation, that the relationship between schooling and the likelihood of having a blue collar job decreases. So the more years of schooling I have, the less likely I am to have a blue collar job, which probably also resonates with our intuition. Now, if I have a lot of education, I may be more likely to work in professional services. And if I work in manufacturing, maybe I go on a traineeship earlier, I have less years of schooling. We also see that this relationship is different depending on the race. So for white, the decline is earlier and stronger than for black and other, for example, here. The question that we now want to answer is whether these differences that we see here in the three slopes is also statistically significant. What I need to do in order to assess this is we need to compare it against the null hypothesis. We do the same trick as before, that for the margins, we are adding the dy dx with respect to our key variable. That's what we're going to do at the bottom here. The only thing that I'm adding is that I'm computing the margins with respect to grade. That's the only thing I'm really adding here. Everything else remains unchanged, but the resulting figure will be quite different, as you will see in a minute. So let's run this again. I need to run the whole thing again so that everything that's stored in my locals is accessible once I go to the margins command here. So I have access to the grade min and the grade max, which are stored in locals further up in my code. No, so remember, they are stored here. Always remember, if you have locals, you need to run the whole thing where the locals are created in one go, so that you can get access to all the values in the margins computation. And again, I added the quietly command because otherwise I will get a very, very long table, which at this point I don't really need. Only Stata needs it to actually compute the relevant values for my margins plot. But for me, in terms of interpretation, at this point, it is less relevant because I'm mainly interested in that visualization. Let's take a look at this. So let's, oh, sorry, I need to run it again because it calls on the locals again. Let me run the whole thing. And then I get this visualization. In this case, I'm also seeing where the effect of these three different groups is statistically different from 0. Visually, I already can see that the lines for few years of schooling are very close to each other, and they are also overlapping in terms of confidence intervals, which already gives me an indication that here for very few years of schooling, like if you only have primary school, now then there's no real difference in the likelihood of having a blue or a white collar profession. However, as the schooling increases in years, we see that the difference becomes stronger. And that we also see that there are stronger differences between the three groups that we have in our data set. And as we move towards higher numbers of schooling years, that's where the differences become lower again. Perhaps what I might be interested in as well here is where exactly is this cutoff point? Earlier, when we looked at our linear regression model and the moderating effect of age, it was relatively clear where that cutoff point was, visually speaking. In this case, perhaps I'm a little less certain, and that's where my vertical lines that indicate where the cutoff points are may matter. What I'm going to add now are two lines, one for the start of where these differences become statistically different from 0, and where the end of that significance area is. Because as you see now, there seems to be a middle range where the values are significant. Again, I have these optional steps 4 to 6 and 7, where I do this. It's the same logic as before, that I do the formal pairwise test with the PW compare, the pairwise compare test in Stata, which is a simple option in the margins command that allows me to actually test these differences and then compare them. And as before, I'm going to store those values in my memory in Stata's memory so that I can call them, and then I can directly compare whether the differences are different across my categories. That's what's happening here. So for each of the categories, I'm computing the margins. For example, if race is 3 or 2 or 1, and do the pw compare command. All of these are then stored in Stata's memory, and I can then compute the cutoff points where these effects are statistically significant. That's what's happening here. And then I'm using those computed values to create those vertical lines where these differences move from being insignificant to significant. So again, a lot of code. Probably it's easier if you walk through this on your own with the annotations. But the basic logic is we want to create those vertical lines where the cutoff points are statistically significant. Let's take a quick look at what this looks like in practice. I run my regression results, I compute all my locals, and then in the end, I also have my second moderation plot, the margins plot. So that's the first one, and now comes the second one, which now adds those vertical lines. In this case, the dashed lines, the vertical dashed lines here, the red, is where the effect starts to be statistically significant. So for the red, that's where the cutoff point is where it starts becoming statistically significant. So this range from year 4 all the way till year 17, that's where the red line is statistically significant. So in that range, for the group black, that's where the difference is between years of schooling and the likelihood of becoming a blue collar worker is statistically significant. So we see the effect is negative. So in that range, it kind of increases the likelihood of having a white collar job or decreases the likelihood of having a blue collar job in that range. But below and above that range, it is not statistically significant. And for the group other, for example, we have a green line, a vertical green line. The dotted green line is where the significance starts. That's at age 12. So you see with the confidence intervals, they just about touch the vertical, the horizontal 0 line. That's why this is probably not yet significant, but at year 12, that's when the significance starts, and it goes to school year 14. That's again when also the confidence interval overlaps with the respective horizontal null line against which I'm testing this statistical significance. So in this way, you can not only test where in which range your moderation becomes statistically significant, but you can also visualize it and show it to your reader, to your audience, where exactly do these differences matter. For the blue line, the confidence intervals are very narrow, and I told Stata, well, if the whole range is statistically significant, then you don't need to add any lines, and that's exactly what's happening. So for the white group, the whole range is statistically significant, and it's also a very narrow confidence band. And that's why there's no line for the white group. No blue line is present here just because now the whole range is covered. We have now the final line of code, which is to save this figure along with my other figures in my document folder. Now I've saved everything. I've my direct effects, I have my descriptive statistics, I have computed my moderation analyses. I've tested where in which range these moderation effects are statistically significant, and basically I'm good to go. Now I've done all my analyses. I can write it up and present it.